Hi everyone. In this presentation, I will explain the importance of data preparation and feature engineering in machine learning. I will also cover how AWS services such as AWS Glue, AWS Glue Data Quality, AWS Glue Data Brew, AWS EMR, and Apache Spark support data transformation and large-scale data processing for machine learning workflows. Now, let's talk about why data preparation is so important in machine learning. First, machine learning model depends heavily on the quality of the data they are trained on. Think of the data as the study material for a student. If the study material is accurate and well organized, the student learns correctly. Similarly, if the data is clean and reliable, the machine learning model can make better predictions. Second, poor quality data leads to poor results. There is common saying in data science that garbage in, garbage out. If the data contains errors, missing information, or incorrect values, the model will learn the wrong pattern and produce inaccurate prediction. Third is the raw data is usually messy. In real-world situation, data is often incomplete, inconsistent, duplicate, or incorrectly formatted. For example, some results may have missing values. The same customer might appear multiple times, or dates may be stored in different formats. Before training a model, these issues need to be fixed. Finally, data preparation is one of the most time-consuming stages of machine learning. Data scientists spend a significant amount of time cleaning, organizing, and transforming data. This process includes removing duplicates, handling missing values, error correct, and standardizing format. In summary, data preparation is essential because high quality data leads to more accurate and reliable machine learning model. Without proper data preparation, even the most advanced algorithm may fail to deliver good result. Now, let's look at some common data quality problems that can affect machine learning performance. The issue is missing value. There are empty and unavailable fields in a data set. For example, a customer's age or income might be missing. Missing data can make it difficult for a model to learn accurate patterns. The second issue is duplicate records. This happens when the data appears multiple times. Duplicates can bias the result because the model may give you too much importance to repeat information. Another common problem is outliers. Outliers are usually high or low values that are very different from the rest of the data. For instance, if most house prices are between $100,000 to $500,000, a price of $10 million would be an outlier. These extreme values can distort model training. Then is the inconsistent formats are also a challenge. Data may be stored in different ways, such as dates written as January 5, 2025 in one place and May 1, 2025 in another. This inconsistency can cause confusion during analysis. Incorrect labels are another serious problem. In supervised learning, labels represent the correct answers. If these labels are wrong, the model learns incorrect relationships and produces inaccurate predictions. Then is the imbalanced data can also affect performance. This occurs when one category appears much more frequently than another. For example, if 95% of emails are non-spam and only 5% are spam, the model may structure to identify spam correctly. Finally, sensitive data must be protected. Personally identifiable information or PII such as names, addresses, and phone numbers should be secured or removed before processing to protect privacy and comply with regulations. To summarize, common data quality problems include missing values, duplicate records, outliers, inconsistent formats, incorrect labels, imbalanced data, and sensitive information. Identifying and fixing these issues is an important part of preparing data for machine learning. Now, let's discuss some common data cleaning techniques used to prepare data for reliable machine learning models. The first technique is removing duplicate rows. Duplicate records can give certain information more weight than it should have, leading to biased results. Removing duplicates help ensure the dataset accurately represents the real-world data. Next is handling missing values. When data is incomplete, missing values can be filled using statistical methods such as the mean, median, or mode, and in some cases a default value may be used depending on the problem. Another technique is dropping unnecessary columns or rows. If certain data is irrelevant, contains too many missing values, or does not contribute to the analysis, it can be removed to simplify the dataset and improve model efficiency. Then is correctly inconsistent formatting is also important. For example, data, currencies, or text entries may be stored in different formats. Standardizing these formats ensures the data is consistent and easier to process. Text standardization is another common step. Data cleaning also involves detecting and handling outliers. Outliers are usually high or low values. They may distort model training. Depending on the situation, they may be corrected, transformed, or removed. Finally, data types and value ranges should be validated. This means checking that each field contains the correct type of data and falls within a reasonable range. For example, an age value should be numeric or should not be negative. After cleaning the data, the next step is data transformation. Data transformation is the process of converting data into a format that machine learning models can understand and use effectively. Since most machine learning algorithms work with numerical data, transformation helps prepare the datasets for training. One common transformation is converting categorical values into numerical values. For example, categories such as red, blue, and green cannot be processed directly by most algorithms, so they can be converted into numerical representation. Another important technique is normalization or scaling. Numerical features often have different ranges. For instance, age might range from 1 to 100, while income could range from thousands to millions. Scaling helps bring these values to similar range, preventing large number from dominating the model. Data transformation can also extract useful information from timestamps. Instead of using raw date and time value, we can create separate features such as the day, month, year, or hour, which may provide meaningful patterns for the model. Another example is data aggregation. This involves combining information from multiple records to create summaries such as calculating the total sales for the month or an average temperature for a week. Data from different sources can also be joined together. For example, customer information from one data can be combined with purchase history from another database to create a more complete dataset. Finally, text data often needs to be transformed into numerical representation. Machine learning models cannot directly understand words, so text is converted into tokens, vectors, or other numerical formats that model can process. Now, let's explore feature engineering, one of the most important steps in machine learning. Feature engineering is a process of creating meaningful input variables, also known as features, that help a machine learning model make better predictions. Features are the input columns used by the model. These are the pieces of information the model learns from. For example, in a customer dataset, feature might include age, income, location, or purchase history. The quality of features has a major impact on model performance. Well-designed features helps the model detect important patterns and relationships between the data, leading to more accurate predictions. Feature engineering also allows us to create new features from existing data. Instead of using raw data directly, we can derive more useful information that better represents the problem we are trying to solve. However, not all features are helpful. Irrelevant, redundant, and noisy features can confuse the model and reduce its performance. This is why selecting the right features is an important part of the process. Let's look at a few examples. A customer's age group can be created from their date of birth. Instead of using their exact date of birth, we can categorize customers into groups such as teenagers, adults, and seniors, which may be more useful for predictions. Another example is calculating the total purchase amount for a customer's transaction history. Rather than analyzing every individual transaction, a summary feature like total spending can provide valuable insight into customers' behavior. Now, let's discuss encoding techniques, which are used to convert categorical and text data into formats that machine learning models can understand. The first technique is one-hot encoding. One-hot encoding creates a separate binary column for each category in a dataset. A value of 1 indicates that the category is present, while 0 indicates it is not. This technique is useful when the category do not have a natural order. The second is label encoding. The label encoding assigns numerical values to each category. This method is useful when the category has a meaningful order or ranking. For example, customer satisfaction label, which is low, medium, and high, can be encoded as 1, 2, and 3. This allows the model to recognize the progression between the categories. The third is tokenization. Tokenization is commonly used in natural language processing (NLP). It breaks text into smaller units called tokens, which can be words, phrases, or even individual characters. For example, the sentence machine learning is powerful can be tokenized into words machine learning is and powerful. These tokens can be converted into numerical representations for machine learning models. Now, let's discuss bias in data preparation, an important challenge that can affect the fairness and accuracy of machine learning models. Bias occurs when the data used to train a model does not accurately represent reality. As a result, the model may make unfair, incorrect, and misleading predictions. There are several common sources of bias in machine learning. The first is unrepresentative training data. If the training data does not reflect the real population, the model may perform well for some groups but poorly for others. Another source is underrepresentation. When certain groups are included less frequently in the dataset, the model may not learn enough from them. This leads to less accurate prediction for those groups. Historical data can also introduce bias. If past data contains unfair decisions and discriminatory patterns, the model may learn and report those same patterns in the future. Bias can also come from incorrect labels. Another issue is missing important features, and finally, the data collection process itself can introduce bias. If the data is gathered in a way that favors certain outcomes, locations, or groups, the resulting dataset may not provide a balanced view of reality. Machine learning workflow often uses sensitive data, personally identifiable information (PII), includes data that can identify a person such as names, emails, phone numbers, or addresses. This information must be protected before it is used in analytics or machine learning. Common protection methods include masking, encryption, tokenization, and access control. Another important principle in data minimization, which means only using the data that is actually needed. AWS Glue is a fully managed serverless data integration and ETL service provided by Amazon Web Services. ETL stands for extract, transform, and load, which is the process of collecting data from different sources, preparing it, and moving it to a destination for analysis. AWS Glue simplifies the process by automatically handling much of the infrastructure and management work. One of its key features is Glue crawlers. Glue crawlers automatically scan data sources, identifies data formats, and discovers the structure of the data. This helps organizations understand and organize their dataset without manual effort. AWS Glue also stores metadata in the Glue Data Catalog. The data catalog acts as a central repository that keeps information about data sets, including their structure, location, and schema. This makes data easier to find and manage. Another important feature is its availability to run ETL jobs. Because AWS Glue is serverless, users do not need to manage servers or infrastructure. AWS automatically handles resources allocation and scaling, allowing teams to focus on data processing rather than system maintenance. AWS Glue works seamlessly with Amazon S3 and many other data sources. This enables organizations to integrate data from different systems into a single workflow. Finally, AWS Glue helps prepare data for analytics and machine learning. By cleaning and transforming data, it ensures that the information is accurate, consistent, and ready for analysis or model training. Now is the AWS Glue Data Brew. AWS Glue Data Brew is a visual data preparation tool. It allows users to clean and transform data without writing code. This can be helpful for exploring data, finding missing values, removing duplicates, and applying transformation. Data Brew is useful when users want a more visual way to prepare data before using it for machine learning or analytics. Another data Glue data quality helps validate data before it is used for analytics or machine learning. It can check whether required fields are complete, whether values are unique, and whether data types are correct, and whether values fall within expected ranges. This is important because bad data can cause model training problems and incorrect predictions. Data quality checks help make machine learning pipelines more reliable. Now is the Amazon EMR. Amazon EMR, which stands for Elastic Map Reduce, is a cloud-based service provided by AWS for processing massive amount of data. It allows organizations to run big data frameworks such as Apache Spark and Apache Hadoop without having to manage the underlying infrastructure themselves. One of the key advantages of Amazon EMR is its ability to process very large datasets across clusters of computers. Instead of relying on a single machine, EMR distributes the workload across multiple nodes, enabling fast and more efficient data processing. Amazon EMR is especially useful for distributed ETL and analytics. Organizations use it to extract, transform, and load data from different sources before performing analysis and training machine learning models. It supports batch processing and large-scale data transformation. This helps it ideal for managing big data workloads that involve millions and even billions of records. Apache Spark is a distributed data processing engine that is commonly used with Amazon EMR. Spark excels at large-scale data transformation and analysis. It can clean data and perform complex calculations and prepare data sets for machine learning much faster than traditional processing methods. Another major strength of Apache Spark is its versatility. It supports SQL queries, real-time data streaming, machine learning applications, graph processing, making it a comprehensive platform for data analytics. Now let's compare Amazon Glue and Amazon EMR. These two Amazon web services, commonly used for data processing and machine learning workflows. Although both services help organizations process and prepare data, they are designed for different use cases. Amazon Glue is a fully managed and serverless ETL service. Because it is serverless, users do not need to provision or manage servers. AWS automatically handles the infrastructure, making Glue easy to set up and maintain. AWS Glue is primarily used for preparing, cleaning, transforming, and cataloging data before it is used for analytics or machine learning. It is a great choice when organizations need a simple and automated solution for ETL tasks. Amazon EMR is a cluster-based big data platform. Unlike Glue, EMR requires clusters of computing resources to process data. It provides great flexibility and control for handling large-scale workloads. EMR is designed for processing massive data sets using frameworks such as Apache Spark and Hadoop. It is commonly used for advanced analytics, large-scale data transformation, and distributed computing tasks that require significant processing power. Key difference lies in the infrastructure model. AWS Glue is managed serverless service that simplifies ETL and data preparation, while Amazon EMR is a cluster-based platform designed for large-scale distributed data processing. Now let's see the machine learning use cases. AWS Glue is used for cleaning, preparing, and organizing data before model processing, whereas Amazon EMR is used when processing extremely large data sets or running complex machine learning analytics workload across multiple machines. In summary, Amazon Glue is the best for automated data preparation and cataloging, while Amazon EMR is the best for processing massive data sets and performing large-scale analytics. Organizations often use both services together, with Glue preparing the data and EMR handling intensive processing and machine learning tasks. And to summarize, data preparation and feature engineering are essential for building successful machine learning models. Clean and well-designed data helps model learn better patterns. AWS Glue is useful for serverless ETL and data cataloging, while Amazon EMR is used for large-scale data processing with tools like Spark and Hadoop. This services helps prepare data for machine learning workflows on AWS. And that should be all for my today's video, and thank you so much for watching. If you have any doubts, feel free to comment in this video so that I can solve your doubt easily. Thank you so much.